We've been talking about quadratics. A quadratic graph is a parabola, and we've also talked about an important part of quadratics is where they cross the x-axis. We call those x-intercepts. We also call them roots, solutions, zeros. They're all the same thing. We've learned to find them in the calculator, from the graph, but now we've also looked at, the table, how to find them from a table, but now we're going to find them by factoring. We've learned factoring. Some of us have. The rest of us need to keep working on it. And so we've also learned that f of x means the same thing as y. What we want to know is, when is y 0? Because that's the x-intercept. That's what's the zeros. When y is 0, it's on the x-axis because y is 0. So let's factor this, and let's look at how I can find. There is a relationship between the factorization of the quadratic and the roots. Let's look at that relationship. So this one, remember, the only way to factor a binomial when there's two terms is if there's a GCF, which a greatest common factor, in this case there is not, or if it's difference of two squares. All right, difference is a minus, 2, a binomial, and squares. Are these perfect squares? Why, yes, they are. The square root of x squared is x, so I'm going to put x and x. The square root of 16 is 4, so I'm going to put 4 and 4. And I need 1 plus 1 minus to make a negative 16, and to make that middle term cancel out. The 4x and the negative 4x will cancel. So what I want to know is when this is equal to 0, because I'm going to change my y to a 0. Now, when you multiply two things together, because parentheses means multiply here, when you multiply two things together and get 0, one of them has to be 0. 0 times anything equals 0. So one of these is 0, maybe both of them are 0. So what I'm going to do now is I'm going to set up two problems. I'm going to say that either x plus 4 equals 0, because that's at parentheses, or x minus 4 equals 0. I have set up two problems. Now I know that this is just a one-step problem. The way to isolate x is to minus the 4. X equals negative 4. Here I add the 4. X equals positive 4. So what are my two roots? Where does this parabola cross the x-axis? It crosses at positive 4 and negative 4. I also can write my roots in brackets to indicate just the x values. So you can write it like this, as the points on the graph, or as this, just the x values. So let's look at one that's already factored for us. This one, they took out a GCF, it's already factored for us. We want to know when the y, the output, is 0. So we're going to set it equal to 0, and if this is 0, I know one of the factors, or both of them, is 0. So I'm going to set up two equations. When is 3x equal to 0, because that's one of the things I'm multiplying, and when is x minus 6 equal to 0. Divide by 3. 0 divided by anything is still 0. So one of the factors is 0. That's okay. Don't be scared of 0 as an answer. Whoops. Oh, I put an equal sign. But now I'm going to add 6 to both sides. And x equals 6. So what are my roots? 0 and 6. I like to write it that way because it takes a few less strokes of the pen. It's nice when they're factored for you. You can go ahead and solve it. But this one's not factored for us. So the first thing I've got to do is factor it. X times x is x squared. I know I need a positive and a negative because a positive times a negative equals a negative. Well, the only two things that multiply to 5, the only factors of 5 are 1 and 5. To get a positive in the middle, the bigger one has to be positive. So 5 times negative 1 is negative 5. 5 plus a negative 1 is 4. Set that to 0. So I want two problems. I want to know when x plus 5 is 0 and when x minus 1 is 0. Now some of you will see a shortcut here, and you won't have to actually write the minus 5 because you'll see that x has to be negative 5 when I subtract the 5. And you won't actually write plus 1 and plus 1 because you'll see that x has to be positive 1. So some of you will see a little shortcut and be able to see that it's the opposite. So those are my roots. Now, got to factor this one. Oh no, there's a number in front of the x squared. When there's a number in front, remember it's not as simple as the others. We can't just find the factors of this that multiply to this. So our first step is to, because this works every time, multiply your 3 times your 36, 108, and then get the factors of 108. Now this is the one that tricks a lot of you because you would think it'd be two positives. Positive times positive is positive. But I have to get a negative in the middle. So they're going to have to both be negative. Negative times negative is negative, but negative plus negative is, yes, is still negative. Okay, let me get my factors in the calculator. For those of you that have forgotten how, you can always go to y equals, and you can put 108 divided by x. Now 108 is the number I got when I did 3 times 36. I want the factors of 108 instead of the factors of 36. Now remember, I'm doing two negatives that add to, what did I want them to add to? Negative 24. Sure looks to me like it's negative 6 and negative 18. If you're bad at your negatives and you're not positive, then you go negative 6 plus negative 18. Look, it's negative 24. I don't know if y'all can see that. Little glare there. Okay, so we've got negative 6 and negative 18. So I rewrite my equation. I leave my 3x squared and my plus 36, but I'm going to replace my negative 24 with a minus 6x and a minus 18x. Those of you who like the box method can do this in the box. I know some of you don't, and you do it by grouping with parentheses, but this is my, these two stay the same. Don't put the 108 in the box. And then the negative 6x and the negative 18x fill in my like terms, but I have no idea what I was about to say. Oh, the order doesn't matter. You can interchange that. Now I find the GCF for each row and each column. This row has a GCF of 3x. Remember, this one and this one are always going to be positive and always have an x. This one and this one also. I just realized what I did wrong. This problem had a GCF. I even wrote this problem and I forgot. So when you get to something like this, where this also has a 3x, 3 times 3 is not 3. You're going to realize you did something wrong because this only works if you took out the GCF first, and I didn't. My bad. I should have looked. So good learning lesson, I guess, to see what I should have done. I also made this much harder on myself by not taking out the GCF. So let's do what we should have done and take out the GCF. You can see they can all be divided by 3. So I take out a 3 and I write what's left. Now, if I set this, okay, hold on, I got ahead of myself. The 3 comes down and let's factor this. Oh, Miss Jones, that is so much easier than factoring the other one. Why didn't you do that first? Because I was silly. All right, x times x is x. It's still going to be 2 minus this. The two factors of 12 that add to negative 8, it's going to be minus 6 minus 2. Now let's set it to 0. All right, can 3 be 0? Of course not. So I don't even need to worry about the 3. I could divide both sides by 3 and it wouldn't change a thing. X minus 2 is 0. X minus 6 is 0. If you see the shortcut, you can see that I do the opposite and I get 2 and 6 for my roots. Okay. Well, sorry about that detour. Now let's look at this one. The problem here is I cannot solve or factor until I set the thing equal to 0. The very first thing I need to do is set the equation equal to 0. This has a 5 on this side. So to get the 5 to the other side, don't I minus it? And there's no like terms, so I can't actually take it away. I can't actually subtract it. So basically, it just moves over there as a minus 5. Now it's equal to 0. Now I can factor. Let's look for a GCF, because we learned our lesson. Is there a GCF? No. Now I'm going to factor it by multiplying the 2. I promise this is what we need to do. Multiply the 2 times the negative 5. Now the only factors of 10 are 1 and 9 and 2 and 5. One of them has to be negative. I said 1 and 9. That's silly. 1 and 10. One of them has to be negative. Since the positive's in the middle, the bigger one's positive. So which two of these add to 9? It's going to be those two. So I'm going to rewrite this with a positive 10 and a minus 1. Because negative 1 and 10 is positive 9. I want to replace this with this. Why? Because I have my 4 pieces now. So I don't care which order you put the 10 and the negative 1. That's a positive. Started to write the negative 1 and changed my mind. I don't know why. What do these two have in common? Only an x. Now, I realize that one's negative. Don't ever lead with a negative. We just don't do that. That's just awkward. So here, 2x. Check yourself. Does 2x times x equal 2x squared? Yes. Good so far. Now, what do these two have in common? When it's a negative in front, I need to take my negative out. So the only thing they have in common is a negative 1. What do these two have in common? A 5. I'm not going to put the negative because it didn't come first. I've already taken care of my negative here, and I know from this that I have to have one positive, one negative. Negative 1 times 5 is negative 5. 2 times 5 is 10. Negative 1 times x is negative 1. Everything checks out. So now I have a 2x minus 1 times x plus 5, and I'm going to set it to 0 and solve. So this one's a little different. I wanted to show you one like this because here I can just do the opposite and get x is negative 5 because all I would have to do to solve for x is minus the 5. But here I've got a 2-step because there's a 2 attached to the x. The coefficient of x is 2. Add the 1. 2x equals 1. Now divide by the 2. So what is x? 1/2. So what are my roots of this one? They are negative 5 and 1/2. If you want to put 0.5, I'm perfectly fine with that. So remember, you must set it equal to 0 first, then factor, then set each factor equal to 0. Now I have my roots. I have my x-intercepts, solutions, zeros.